Hello, good day viewers. In this tutorial, I would like to prove that the square root of 2 is an irrational number. We have learned that the square root of non-perfect square numbers are always irrational. So I would like to prove it today. But what is a rational number? A rational number is a number that can be expressed as a fraction, right? An integer divided by another integer to the lowest term. For example, if I have 3 divided by 2, for example, this is a rational number, or 0.2, because 0.2 can also be expressed as 1 divided by 5. So once you can take another integer, divide by another integer to get that particular number, therefore that particular number is said to be a rational number. But there is no any two integers that you can divide to get square root of 2, meaning square root of 2 is a rational number. But we are going to prove this by contradiction, meaning we assume the opposite. We are going to assume square root of 2 is a rational number. So by contradiction, let's get started. Let's assume that square root of 2 is irrational, meaning it can be expressed as numerator divided by the denominator. We may choose a divided by b, for which a divided by b is to the lowest term. They are what? Non-reducible. For example, if you have 2 divided by 4, we know that 2 divided by 4 can be reduced because 2 is a factor of 2. 2 is also a factor of 4. So you can reduce it to what? 1 divided by 2. So we want that fraction to the lowest term. We assume that this is non-reducible. It is to the lowest term. So if this is true, let us square both sides in order to eliminate the square root here. If you square both sides, you are left with 2 here, and this will be a squared divided by b squared. We can multiply both sides by b squared, such that 2b squared is equal to what? A squared. But what can you remember about an integer squared is still an integer, because if 2 is an integer, 2 squared is 4. 4 is also an integer, meaning that the whole of this b squared as well as a squared, they remain integers. But whenever you take an integer, you multiply it by 2, it will result to what? An even number, which means what? A squared is even. And remember that if you square an even number, you're still going to get an even number. So a square here stands for what? A multiplied by a times a. A times a is a squared. Remember, if you take an odd number, example 3 is an odd number, you multiply it by another by itself, which is the same thing as 3 squared, you're going to get 9. 9 is also an odd number. So square of an odd number results to odd number, and if it is even, for example 2, this will give us what? 4. If you square an even number, you're still going to get another even number, which implies that what? A is also an even number. A is also an even number. It cannot be odd, because odd square will not give us even number. We got this even number from here because 2 multiplied by an integer will be what? An even number. All right. So from definition, we know that even number can be defined as what? 2k, for which k is also an integer. So we can replace a with 2k. So let a, let me use equality sign here, be equal to 2k, because we have seen that a is an even number. So if that is the case, we can plug it back here. Instead of a squared, we write 2k, because it is an even number. So let's plug it back here. Therefore, we have a 2b squared to be equal to what? 2k whole squared. If you expand, you have 4k squared. Therefore, 2b squared equal to 4k squared. We can divide both sides by 2. If you do that, if you do that, 2 will go into 4 exactly 2 times. So you have b squared equal to 2k squared. 2 times something, meaning an even number. Therefore, b squared is also an even number. B squared is even, and if b squared is even, it implies b is also an even. Okay, if a is even, b is even, it means that the square root of 2 is equal to even divided by even. Therefore, square root of 2 is even divided by even. The purpose of this proof is to prove this wrong. Remember, we know that square root of 2 is irrational, but we just assume it is rational. If it is rational, to the lowest term, we have a divided by b. Remember, we said that a divided by b is to the lowest term. It is non-reducible. But having even divided by even, it means what? Both the numerator and denominator have a common factor of 2, because 2 can divide an even number as well as what? 2 can divide even number and another even number. So let's assume that this is equal to 2 multiplied by a certain integer divided by 2 multiplied by a certain integer, because they are even. This is definition of even. So you can see that 2 cancel 2. Oh, we don't even have to cancel because we can factor it out. We have a common factor of what? 2. And since we have a common factor of 2 between our numerator and denominator, it fails this assertion, because we assume that this is to the lowest term, but we realize we have a common factor of 2 in the end. So since the assertion failed, it means that what? This is an irrational number. This implies that the square root of 2 is what? Irrational. And that's it. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.